Yeah, mute your shit.
Might want to just mute yourselves first, unless you guys are talking. All right, we're gonna start. So, introducing Clark here at the office. I guess you could see him.
What's up, Clark?
Hey guys, good morning. Ready to rack your brains?
Oh yeah, bright and early.
Okay, so just a quick introduction. Again, my name is Clark. I'm a student at CDU taking Master of Science in Computer Science. I did some software development, cloud technologies, and some blockchain. So without further ado, we'll be talking about blockchain. Basically, I'll run through the concepts and let's see what else you guys wanted to know more about after the presentation. Okay, so let's start. Basically, a lot of people know about Bitcoin. So blockchain is the technology behind Bitcoin, record-keeping technology behind Bitcoin, okay? We'll start off with some use cases of blockchain. We're very familiar with cryptocurrencies like Bitcoin, Ethereum, smart contracts, financial services and banks, video games, supply chain. Next. So we'll now try to deep dive in dissecting what really is blockchain, right? First things first, you have to remember that it is distributed, decentralized, and a public key. It also allows a block of information to be created and stored in a chain. And it's basically a growing list of records. So let's try dissecting the. So we have centralized, decentralized, and distributed. So basically when you say centralized, you have, let's say, a central authority or a third party that manages everything, let's say a clearinghouse for banks, right? For decentralized, it just means that you don't have that central authority figure. Every other server or nodes or there would be a bunch of third parties that would do the verification of the information. For the distributed, it just means the location. Okay, we'll further go deeper into this. So when we say centralized and decentralized, these are levels of control. And again, when they say centralized, only one entity holds the control. When decentralized, it could be everyone who participates in the blockchain. In terms of distributed and non-distributed, there are just differences of location. So an example, so when we say centralized and non-distributed, we could say you're using a Microsoft Word application on a PC and it's running Microsoft Windows operating system. Microsoft controls the application, centralized. The application is located in your PC, non-distributed, single location, single physical location. Decentralized and non-distributed. If you know Linux, Linux is basically another operating system, an open source operating system. Let's say you have a word processing software inside of your Linux. Because Linux is built on open source software, not only one person or entity owns it, it's basically a global community. You can say that it's decentralized. The application is still located in your PC, it's still non-distributed. Now, let's say when we have the word centralized and distributed, a perfect example would be cloud service providers like Azure, Amazon Web Services, Google Cloud Platform, and other cloud service providers. Let's say they offer a data storage service, and that data is usually shared and replicated on different machines in different locations and in different regions. So you can say that one is distributed, but then again, only one cloud service provider controls all. Let's say all of your data storage servers are with Amazon, it's still centralized. Next, decentralized and distributed. Again, this is the blockchain system, and basically Bitcoin is also blockchain. So it cannot be altered by just one entity. So usually when you want to alter something which is close to impossible, you have to alter all of the machines that holds the records. It also runs peer-to-peer network spread across the globe. That's why it's distributed. I hope this clears up decentralized and distributed. Next, when we talk about blockchain, it's basically a subset of distributed ledgers. Distributed ledgers is a type of technology that where you store information, just for example, accounting information, right? So the one thing to differentiate between them is different distributed ledgers do not require such a chain like a blockchain, and distributed ledgers do not require proof of work. Proof of work meaning miners mining, getting a block. We'll talk more about that later. So now you can see cryptocurrencies is a subset of blockchain. Again, blockchain is the technology that enables the existence of cryptocurrency, and there's other things like smart contracts. Now we go down deeper with a centralized ledger. As I said before, a perfect example would be banks. Let's say you have a check and you want to transfer money from one bank to another. It usually goes to a clearinghouse, and that clearinghouse is your central authority to check and verify and send it to another bank. So basically an intermediary, okay? And one thing that we don't like about a centralized is it forms like a bottleneck, and at the same time, it has a single point of failure. If let's say I'm a hacker, I can just attack the clearinghouse and everything goes down, and all of them cannot transact to each other, the different banks. Next. So distributed ledger is basically removing that central authority. Let's say I have bank A, B, and C, and D. I would share my information across those four, and they all hold the same record of information. So here's the difference. Central ledger would only have one entity, and distributed ledger would be all the participants. So what is public versus private ledger? Public ledger, basically, if you talk about blockchain, it's public blockchain. And private ledger, when you talk about in blockchain terms, it's a private blockchain right away. So public, everyone can participate. Let's say my computer, your cell phone, it could be a slave or a network to participate in that blockchain. In private, it just requires an invitation, meaning if I'm a bank, I don't want other people to have access to my blockchain, right? Or my ledger. Example of public blockchain, Bitcoin, which is a cryptocurrency. And as you all know, Bitcoin has a finite resource. And participants in the network, which we call miners, are rewarded with Bitcoin tokens. And we'll talk about mining and miners. So if you all know Snow White and the Seven Dwarfs, they were mining actually diamonds, but again, gold, same diamonds, they're finite resources, right? So even Bitcoin has a set finite resource. I think right now it's around 21 million Bitcoins that are only available digitally or in the market. So how does this actually work? So let's say you have a computer at your home. It's also called a server. Computer is just a server. Let me correct myself. So basically, the one who hosts those Bitcoins, they have servers, and basically they would generate this complex math problems. And you, as a miner, let's say you have a PC at your home, you would use your PC to try to solve those complex math problems. And if your PC gets to solve those complex math problems, you get a Bitcoin or a block. So here's a good example, like this one, Multibit. It has a graphical user interface, a GUI, that lets you create your wallet. And as you can see on the left pane of the menu, you would see your wallet and the Bitcoin. You need to create an account, and you need to also put where the file name is. Also, this is another Bitcoin mining app. And basically, you would define your server, you add your username, your device, you would put whatever your CPU or GPU that you want to use. And usually, you would have a web page related to that app provider, and you could see your username, your Bitcoin address, your unconfirmed reward, and confirmed reward if you were able to solve that math problem. So question is, how do you create the next block in a blockchain? Again, that is to get the Bitcoin, right? So each participant in the network must solve a complex cryptographic problem. This is also known as proof of work, okay? Whoever solves the problem earns the right to create the next block, gets the reward, which is the Bitcoin, if you're gonna talk about cryptocurrencies. So what are these computational problems? It looks like just a math problem. It really is. And if you know how to solve math problem, maybe you can do it, but not really. So Bitcoin uses these SHA-256 hashing algorithm. Basically, it's just a bunch of numbers and alphabets, and that's the hash code, or that's what's inside a block. Okay, so let's say this is the given hash code of the three previous blocks. So it's changed together, 3 blocks. And let's say you want to build the next block. So basically, your computer have to keep solving or keep guessing the cryptographic encryption. Let's say you need to try to find the next hashing algorithm. So the above is the 3 previous blocks, and the code, the hash code below is the guess of your computer. Now the computer tries to guess 13 leading zeros, meaning 13 zeros in front of the hash code that you're trying to guess. So let's say the second guess with 2 leading zeros, close, not really. And let's say after 10 million computations, you get to find out the hash code. And again, only the blockchain server would know the next hash code to be unlocked. And therefore, other miners will now build on top of your block. So what would happen? You have the 3 previous blocks, and then you build the 4th block, and now other miners would build on top of that 4th block. Because again, it's a continuous information. Next. So if you are the first to solve the hash of the next block, you get the next block. But if another computer were able to solve it, you have to start over again and try to compute for the next block after that. So how long is it to mine 1 Bitcoin? There is really no set computations for that, but there are 3 factors. One is what kind of mining hardware you are using, meaning your PC. How much hash rate does your mining rig generate, meaning how many hash codes can it solve. And third, how long does our mining rig run for? It just means that how long would you put your servers or computer up and running? Again, why is it so hard? Because cracking this hash algorithm is close to 2 raised to 256 possible combination. And as you can see below, that's 78 digits, okay? Long. So here are other types of, people who try to mine Bitcoin. This is their, let's say, data center or servers. So it's really hard to compete with them Like, let's say you have your personal computer. Before, it was possible, but right now it's really close to impossible. If you try to mine 1 Bitcoin, the time it takes and the time that your computer is running, processing, and you get the Bitcoin, you might have a negative, like a negative profit on that one. So private blockchain. An example would this be Hyperledger Fabric, and that's a typo with the finite resource. Don't try to remember that. And one thing to note about the difference between public and private: public is permissionless, and private is permissioned blockchain. This is one of the very popular private blockchain or private distributed ledger provider. So right now, currently as of now, Hyperledger blockchain projects, they have implemented and is being used in production. One is food source tracking, transparency on airline industry ticketing, traceable invoice to streamline accounting process. So here would be a cross sections of what are public and closed, public and open, private and closed, private and open. So like, let's say public, we have voting records, whistleblower. This is really good for voting because we don't really want any changes in the voting ballots. Public and open would be currencies like cryptocurrencies. Anyone can participate, anyone can buy and sell. Private and closed, you don't want any other involvement from non-participants. So military, tax return, contract, construction. Private and open, you would have supply chain. Definitely, you would want other people to see, let's say your chicken is really organic. So people cannot change the information that says that, oh, this came from a very organic farm in the US, while it's really not. It came from somewhere else. So it's really helpful on that aspect. So applications of blockchain in financial services, there's a lot. So there's 4 big categories: smart contracts, digital currencies, record keeping, securities. I'll give a moment for you guys to look at this, like say 15 seconds.
Any questions so far though?
Yeah, I should have had if I'm doing fast or not. Are you guys okay?
I actually muted you guys, so you might want to unmute yourself before you guys speak.
I guess my only question is
Yeah,
with
good.
the finite amount of sources, when people are mining and they're trying to build off each block, when would it stop then, where all of the blocks have been mined, I guess?
Yes, correct. So basically, like Bitcoin, they would have 21 million coins only. So the closer you are to that limit, the harder it is.
Okay.
Okay, I'll move on. So let's go back again. So what is a block in a blockchain? Basically, there are blocks in a chain. Hooray, hooray! Now you understand blockchain, right? So let's say each block would contain its own hash. Let's say your input, a string input, would be Concord, and you will be given this hashing algorithm. And if you change that to any word, let's say Concord Ventures, you would get a different hashing algorithm. But something to note, if you change it back to the same word, you would get the same hash algorithm. So you can still hack it if you know, let's say, the word that they place inside or the information they place inside the block. And again, they are connected with this hashing algorithm. And why is it so hard to hack? Let's say you have a total of 6 blocks. So let's say block 20 you created, there's timestamp, there's a transaction encryption. You did the same for block 21, you did the same for block 22, and come block 23, you want to alter the data. This is so hard because one of the things that you have to take note of, the hashing algorithm would change every time a change would happen in, let's say, block 23. It would be a chain effect, meaning. And let's say block 24, it does not match the stored hash there. Basically, the blockchain would reject that. And another thing to note that, let's say you have a blockchain, public blockchain, and you have, let's say, 100 servers. If you want to hack them, which you definitely don't want to, you just need to get control of 51% to get for them to get to change the information that you want. So that's like a majority stakeholder. Is that correct? 51%. Basically, again, if you were able to get control of 51% of the computer and instruct them to change the data, you're able to. But then again, that's so super hard. So let's talk about smart contracts. Smart contracts are basically self-executing contracts between buyer and seller. The code is basically uploaded in the blockchain. Usually they're anonymous parties. They don't need to know each other. And there's no third party or central authority involved. So a traditional contract would have parties. You will have a contract, and again, a third party and execution. You can say a lawyer, right? For smart contract, you just remove the central authority. So smart contracts would be great for everything related to contracts, really. Let's say having an agent and your celebrity, like doing some bookings, doing some venues. It avoids the need for haggling for prices, and now everything's visible. And basically that's it. So that's a reference. And just to take note of, Ethereum is a blockchain. Hyperledger Fabric is a distributed ledger. And even cloud service providers provide ease of deployment of creating blockchains. So let's say me, I can't really invest on a lot of computers, but I can go to Amazon and have them provision my servers to create a managed blockchain. And that is way cost effective comparing to creating my servers. And what else? And before we go to this question, I can go back to any slides if you have questions. And what time is it for now?
It's about 8:30.
Okay, so that's good. So what I'll do instead is I'll try to go back to the slides and slowly navigate through them, and let's see if you have questions. So uses of blockchain. So if we go back here, I don't know much about escrow, but with smart contracts, you can automate them. For financial services and bank, you speed up back office settlements. So even internally, you can have your, let's say, Goldman Sachs, they have their own blockchain to serve that purpose. Video games, there's this famous cryptocurrency called CryptoKitties.
Kitty.
Yeah, it's basically, I don't know, I've never tried it, but basically you just save you save cute cats as digital assets. Supply chain, a lot of people have been using it. Again, this, trying to have the immutable information that, let's say it's organic, but how sure are you? He says so. But now with blockchain, you would see that information, and you can change that very easily. We talked about distributed, decentralized public ledger, growing list of records, centralized, decentralized as a level of control, distributed and non-distributed as locations, which are these.
So for blockchain, is it always decentralized or?
It is always decentralized.
Okay. But then would it be at some point a distributed blockchain?
It is a distributed blockchain.
So it's both?
Yeah. So one thing to quickly remind people is when we say non-distributed, it is just located in your PC, or let's say local in Concord Ventures. That's still one location. And let's say what else. So one thing that a lot of people also miss is that blockchain is an implementation of distributed ledger. And distributed ledger is basically handing, let's say, a piece of paper to you, and you all have the same information. And whenever, let's say, I want to do a change, I need to verify with you, or 50%, 51%, to be able to make a change. And again, cryptocurrency is just a subset of blockchain. Clearinghouse. Everyone holds the same information. Okay.
So for a distributed ledger, whoever makes a change.
So for distributed ledger, first things first is everyone holds the information, and if they want to make a change, they must make a consensus.
So that's the 51% you were talking about. For centralized.
It's the basic, like you send a check, it goes to and that's the bottleneck, right? And the problem with that is if this goes down, everyone can't operate.
Exactly. Yeah.
Yeah.
Yes.
So moving on, basically, if it's a public ledger, you would have the public blockchain as well. Private ledger, you would have the private blockchain as well. Everyone can participate, and private requires an invitation. And we talked about this, Snow White and Seven Dwarfs. You need to watch it. And we talked about mining. Basically, again, the servers that implemented Bitcoin would give this complex math problem. Your computer or your bunch of computer just needs to solve them to be rewarded with the block that holds a coin.
I don't actually understand this because now the way you usually just buy Bitcoin.
Oh, as a user, you buy Bitcoin and you exchange a value, your fiat currency, right? But if you want to
Get your own
without
buying.
exchanging, so it's like gold. You go to a gold mine, if you can buy right away in stores, right? But if you want to have a low cost, you try to mine it.
Oh, that's
Right?
okay. I was like, could those just.
Let's go back to Snow White and the Seven. You have to mine it.
I wasn't sure what you mean by mining.
And if I'm the miner, a good example would be I would use my computer, and my computer would be the miner, and that computer would be now a slave to do some computational problems and try to solve that hashing algorithm. If my computer have a very high CPU, GPU, and got lucky and solved that next block, I get that next block.
Okay.
And I get the, let's say, cryptocurrency. Yeah.
But you can't do that anymore with just normal.
So then,
The time before, yes, you
Yeah,
can.
like 8 years ago.
8 years ago, you can, but because a lot of people like did it full blown, and it's becoming more finite, so it's becoming more harder. And again, the hashing algorithm also includes the previous blocks, like the signature of it. It also holds the other blocks. Your question?
kind of answer that. But so once you you solve the first block, essentially, right? You create your own, the hash, and then it would make the next one easier for you to solve, but harder for everyone else to solve then?
So,
they have to figure out your hash previously of that block,
Mhm.
and then the next answer to the next problem, right?
mhm.
So like if you were to solve the initial one, it should be easier for you and harder for everyone else.
Yeah, I would believe so. Yep.
Okay.
Mhm.
And then as far as the wallet goes, that was one of my questions.
Yeah.
Was once it's stored in this wallet, it's off at like 51%. Say someone, because of your hash, and they could like, I guess, could they like go back and see your previous hashes and stuff like that in your tag of say Concord, and then if they were able to solve that algorithm, do they then get it if it's 51%?
Thing is, you're correct that blockchain isn't 100% secure. It's definitely hackable. And nowadays, people have been trying with quantum computing. Basically, quantum computing is just a lot of computational power to be able to solve this hashing algorithms. So, and you would have a lot of stories as well that cryptocurrencies got hacked. So it's not totally secure. Okay.
But there are ways to say, be able to block them out with certain, I guess, like walls that you can put up within your wallet, something like that.
So the thing is with, let's say, smart contracts. Smart contract is basically blockchain, and you put your code inside there.
Okay.
So even though, let's say, blockchain is secure, but if, let's say, your contract, the way the code that is your smart contract is not secured or has weird words or whatever, you mess it up, it's still less secure. Correct. Yeah. So there's a lot of other factors that can make your blockchain not secure as well. Let's say you're trying to implement a private blockchain, but your network is out in the public. So that's another risk or another attack vector for hackers. So again, proof of work is basically solving the problem with a hashing algorithm. What else? So I guess this, let's see. So Hyperledger Fabric is one of the things you want to look at because it's kind of popular right now in enterprises. Let's see, and this would be a good snapshot of how is it being used right now in the financial services. And don't worry, I'll send Justine the slides so you guys can browse it. And I think she recorded this one.
Yeah.
Okay. And I'd like to ask a question. So, in the foreseeable future, what do you guys want to know more about? Like, we can go deeper with blockchain. Do you want more use case scenarios? You can talk about something else. Security in the blockchain. Applications of blockchain. Okay. How about other people?
So we need to know about fintech. I mean, that's,
Fintech will be a good foundation for everyone, I think, as well.
I mean, and because most, if we're going to bring in tech companies,
Mhm.
it's mostly going to be under fintech.
Mhm. And just a quick thing about fintech, it's basically just a new buzzword. There's really no, if you would grab other people's opinion, there's really no fintech because the financial services were the first one who used a computer.
Mm-hmm.
So basically,
It's all fintech.
it's all fintech. Yeah. Okay, so basically, I'll just let you guys vote and take some time and have Justine know about what's the next topic you want. It could also be anything aside from this one. Okay.
How do we hack to get Bitcoin?
Hack?
It should be the next talk.
Sorry.
What do we do?
That would be a very interesting topic as well.
Mhm. What do we do, Clark?
You would need quantum computers.
How much do we need?
Oh my God, super expensive. Super expensive, very, very expensive. And again,
Bankroll operation.
like, we talking about fintech and this blockchain, I mean, the finance guys really likes to have this blockchain. But ever since, the problem is there's this chasm that's preventing them to implement a blockchain. Why? Again, it's super expensive. Let's say Concord would want their own blockchain to store their information. You would need to have a lot of servers, and you would want them in different locations.
So that would be a more secure blockchain. Is that it?
Yeah, you would want to implement that kind of blockchain, different locations. And the other thing that is very costly is you need to have a professional, let's say a blockchain expert, to maintain those. So the cost just ramps up. But now we have a lot of cloud service providers that would enable you to provision those servers on your behalf. And it really drives down the cost. So
Like they're renting it.
yeah.
Okay.
Okay.
I bet you Amazon should buy it.
And I think Facebook as well has their own Bitcoin. Yeah.
Question.
Oh, go ahead, Eileen.
Question. So, so does that mean that blockchain is the way to go? Because it seems like, it's such a big thing and it started, many years ago, and there are companies that are starting their own crypto. And what's the mentality with blockchain, and, what are some of the backlashes? How do we have to prepare ourselves to kind of shift in that direction? Is there a need
I would
for-
say a lot of the opinions will be blockchain is here to stay. Blockchain is the future. It might not adopt very quickly, but think about it like the TCP/IP, which is basically the internet. It didn't really adopt it right away. It was invented for military use, and they didn't really use it for commercial and consumer use, but it became a foundational technology. So this blockchain is here to stay, but again, the question now is how fast would be the adoption? Because
Right.
let's say you would have this cloud service providers giving you easier access to create your blockchain technology. But now the next question is, there's a lot of moving parts for blockchain to be implemented in the economy and the political standpoint, and right, because right now even let's say banks would argue about the currencies.
Yeah.
But next time, smart contracts. Lawyers would argue about smart contracts. You're taking away their jobs and whatnot. Voting. Politicians can cheat because now it's so that's a big question.
Right.
Thank you for your question.
Any more questions, guys? Should we?
How about the Indo people?
Shifa Putri?
Can you hear us?
No.
I have a quick question.
Oh, I think.
Someone
Jay,
had a
do you have
question.
a question, Jay?
Yeah. Is there any specific reasons why countries are banning cryptocurrencies and blockchain, or is it just because they can't regulate it?
I believe you're right because one is they might not have the technology to regulate it, and the other thing is it takes away intermediary fees. I mean, how banks earn money, right? Because basically now, let's say me and you, we could just transact with each other with no other third party involved, and that saves us cost from us. But then again, the third party who provides that service now goes out of business. They have to reinvent themselves as well.
I see. Thank you.
Okay. Okay, Nicola.
No, but wasn't it that I read somewhere that this was actually conceptualized or invented to take out those regulations, to do away with those regulations, to go through the barriers foreign exchange, monetary regulations from country to country.
Mhm.
You know,
Yeah, that's the
that was the initial reason.
that is basically the reason. But now you would ask the question: would, let's say, a country like that, would, let's say, China want that to have quick foreign exchange? So those are also the things that I haven't looked at, but I believe it because it will basically um, be on whatever the standpoint of whatever position or party or country. It really depends on those. So as in every technology, I'll give you a perfect example. Like in the Philippines, we were so happy when Uber came,
Mm-hmm.
but because a lot of our politicians own the taxis, it's a known rumor, so they don't want it, and they kick out Uber, and then they have Grab right now, but it's so freaking expensive compared to Uber, and the service is way bad because Grab drivers have the option to cancel. The Uber drivers don't have the option to cancel. So
And then now that Uber's not there, now they're all the earnings.
Monopolized.
Yeah, it's
now.
monopolized just to Grab, I guess.
So I guess I have one more question.
Go ahead.
I was thinking kind of like from an investing aspect, like with Facebook and what I read and stuff, is that a lot of them are investing in like buying cryptocurrency, but they're holding it, and how that's going to affect the way like they would structure deals potentially, like using it as a means of exchange. So instead of simple like using it as a currency itself, do you think that would happen in the future? To say like
a bargaining chip.
exactly,
Mhm.
because if you have an X amount of holding and stuff like that, it does vary. Like with price, obviously it's a finite amount,
Mhm.
but how that would be transferred, I guess, is like if it was a means of currency, how would it be transferred throughout?
I'm not quite sure on that part yet, but I believe it's like just like a stock of a company, right? It could become something like that, but that's totally something new, and it's really would be nice to follow along the news and updates with them.
Mhm.
Yeah. Anything else?
Okay. I guess our blockchain meeting with Clark is adjourned.
Thank you, Clark.
Thank you guys. Yep. Sweet.
Thank you.
Thank you.
Um,
I actually
Right.
thought part two.
Stop the recording, but I'll have to talk to Eileen, but everyone else you guys can
You guys can
log
Oh,
off.
kick
okay.
everyone out.
Okay.
Huh? Take care of yourself.
Kick everyone out.
Kick
I mean,
Oh.